Hello everybody. Today we people are going to discuss about friction. We are just taking up the concept of friction, which of course fetches you 1 question to 2 at EAMCET level. Friction is nothing other than the opposing force which tries to oppose the relative motion of a body. Truly speaking, the frictional force is directly proportional to normal reaction in brief. So whenever we consider force of friction, that can be taken mu times r, which of course we used to take it as the coefficient of friction. So this coefficient of friction, of course, while talking about static friction we speak out, this rolling friction we can speak out. Static friction is the highest one and rolling friction is the least. Based on this major concept, we people can develop this particular chapter further. Let us discuss some of the applications. One general application is this: force of friction is independent of 2 aspects. 1. Static friction is independent of the areas of the bodies which are in contact with each other. Suppose if area is doubled of a body or becomes half of a body, whatever be the case, the total normal reaction acting on the body does not vary. Thereby the force of friction is independent of the area. Exactly in the same manner, force of friction is even independent of the speed of a body also. Speed increases a little or decreases a little, hardly it matters. You will not find any change or variation as far as the force of friction that is concerned. Let us take few applications in the form of problems now. The very first problem that is appearing here: 2 bodies having the same mass, 2 kg each, have different surface areas 50 meter square and 100 meter square in contact with a horizontal plane. If the coefficient of friction is 0.2, the forces of friction that come into play when they are in motion will be in the ratio what? That is a concept. Just now I have mentioned the force of friction is independent of area of the bodies which are in contact with each other. Thereby 50 meter square and 100 meter square does not matter. When their masses are same, their weights are also going to be equal. The normal reaction, whatever that is acting on the bodies, will definitely be the same. Therefore, there will not be any sort of a change as far as the force of friction that is concerned. Therefore, you can all understand that the force is going to be the same. 1:1 will now be the result over there. The option is going to be the first one. Let us now take up the second problem over here. A block of weight 20 Newton is pressed between 2 hands and each hand exerts a force of 40 Newton. If the book just starts to slide down, the coefficient of friction is. One point you can all understand here. This is the book, for example. We just are now applying forces on both sides. The force whatever we are applying, that in turn we will get in the form of reaction. Even here also in turn we get in the form of reaction. There will definitely be a force of friction that is acting upward here between the first hand and this side of the block. Likewise between the second hand and the other side of the book. So 2 forces of friction, they are now going to act on the system. The weight over here of this particular book is now going to act vertically downward. So if you consider this point over here exerts a force of 40 Newton, then automatically you can understand the normal reaction also is going to be 40 Newton. Weight is being 20 Newton over here, then what will be the force of friction? Force of friction actually is nothing other than mu times r. That r of course is going to be the normal reaction here. The coefficient of friction we just want. What is the upward force now that is acting? It is now 2F. That now should be equal to the weight of the book if it is to be at rest. That is the concept. So you can understand the force of friction over here is going to be twice mu times normal reaction, that is going to be 40. That now is going to be the weight, which is going to be 20. Now you can cut this one over here. Mu now becomes 1/4, which now becomes 0.25. 0.25 is going to be the value of coefficient of friction there, which is again the first option once again. If you just go to the next number over here, an eraser weighing 2 Newton is pressed against a blackboard with a force of 5 Newton. The coefficient of friction is 0.4. the minimum force parallel to the blackboard required to slide the eraser upwards. Every word that of course has been given is to be taken very care of while doing EAMCET examination. Because here he is talking about the eraser not to come down, it is to move upward. That is a condition he is mentioning. If I consider this is the eraser, you are just pressing that one with a force F. What is the force over here we people are applying? That is now given 5 Newton. And what is the weight that has been mentioned of this eraser? It is now given 2 Newton over here. But as I said earlier in the previous problem, the moment you are applying a 5 Newton force on that, same will now become normal reaction also. And we know pretty well, along the surface, there will be force of friction which is vertically upwards that is acting on it, which now in turn is mu times r. What is the concept over here? Coefficient of friction that is given 0.4 and r is going to be 5. Totally, you will be getting 2 Newton acting upward. And weight also is 2 Newton. In fact, the body will definitely be at rest, there is a possibility. But what exactly the question that is asked over here? Minimum force parallel to the blackboard required to slide the eraser upward. When the eraser is going upward, the force of friction also is going to act downward. What is the force of friction value we people have got? 2 Newton. That 2 Newton also will be added up to this weight in the downward direction. Therefore, the effective force over here required will now be 2 Newton plus 2 Newton. Total it will now be 4 Newton as such. By any chance, if the student is unable to look at that word upward, then naturally you cancel these two off or something like that. That should not happen over here. That's a condition. Now come to the next number over here. A car running at 72 km/h on a level road is stopped after traveling a distance of 30 meters after disengaging its engine. The coefficient of friction between the road and the tires is how much? Given the acceleration due to gravity value as 10 meters per second square. That is the concept there. A car running at 72 km/h. All of us in fact we know km/h, to convert that one into meter per second we need to multiply it by 5/18. So what will be the velocity that of course a car has got? Simply 20 meters per second. That's the value. Now it is stopped after traveling a distance of 30 meters. So this now becomes initial velocity for the body. And what will now be the final velocity? It should be 0 because the body should come down to rest. And at the same time, distance traveled is given 30 meters. This actually the data that has been provided to us. So with this data, acceleration from kinematical equations, you can calculate this one as u square by 2s. V square minus u square is equal to 2as formula. Applying that one, you can write u square by 2s as the value of a, which now becomes u square being 400 by 2s means 2 into 30. This 0 you can cut it off. This one cuts off 20 times. 20 by 3 meter per second square. That's the value of acceleration. But the question is not this. What is coefficient of friction? The question, which now can be written as A by G, because we know F by R, force of friction by normal reaction, is coefficient of friction. F can be written as MA and R can be written as MG. M getting cancelled, A by G will now be the value. And what will be acceleration we have got? 20 by 3 into what is acceleration due to gravity that is given? It is given 10. If you cut this one, 2 by 3 will be the value. 2 by 3 in other words, you can write around 0.666 like it recurs. Therefore, we can take it as 0.67. That's the concept. Now, let us go to the next number, which is altogether a different model. A block of weight 100 Newton is pushed by a force F on a horizontal rough plane, moves at an acceleration of 1 meter per second square. When the force is doubled, its acceleration becomes 10 meter per second square. The coefficient of friction is how much? In this case, you should understand the motion of a body along a horizontal plane. That's the concept first of all. Block of weight 100 Newton. You can definitely guess when G is 10, the mass over here will be 10 kg, because 100 Newton by 10 meter per second square gives you the value of mass. And of course we know a force, that is F, that is acting on it. Force of friction acts in the opposite direction. Weight is going to be 100 Newton over here, and normal reaction is going to be R over here. Thereby the force of friction, which is mu times R, you people can write now mu times the value of R, which is 100. This is the force of friction that is acting. But acceleration of the body is the resultant force by mass. What is the resultant force over here? Force applied minus the force of friction by mass. That is the value of acceleration. What is the acceleration given in the problem you look at? It's 1 meter per second square. That is the acceleration when force F is applied on that. So if I just write this is 1 and F is not known, small f is already we have taken up. It is mu times 100 by mass is as well, we know that is 10. So what you can understand from this one, F minus 100 mu is equal to 10. That is the equation 1 what we can understand. Exactly in the same manner, when you take the second sentence over there, when acceleration is becoming 10 meter per second square, when force is being doubled, then you can rewrite the same equation this way. 2F minus 100 mu will be the same, there will not be any change, is equal to this being 10, 10 times 10 now becomes 100. Simple. Now you just simplify these two equations, automatically the value of mu comes to be 0.8 over there. But one thing you people should understand, mu is simply a ratio of similar physical quantities, therefore there will never be any sort of units for that. That is a concept you need to remember. So this answer, of course, automatically you will be getting 0.8. That is a concept here. That's a question number 5. Altogether a different model. Let us now take the commonly asked question at EAMCET examination. This type of a question has been appeared earlier several times. A body slides down a rough inclined plane of angle of inclination 30 degrees and takes time twice as great as the time taken in slipping down an identical frictionless plane. Come to the concept here. Time taken on a smooth inclined plane, if I take, that is under root 2L by G sin theta. That is the formula. L being the slanting length of the inclined plane, theta being the angle of inclination over there. Like exactly like that, T on a rough surface, suppose if we write it, it is under root 2L by G into sin theta minus mu cos theta. That is the formula what we people are having. So if at all you read the question there, it takes time as great as the time taken in slipping down an identical frictionless plane. That means T rough value is equal to twice, that is the concept given over there, twice T smooth. That is the concept what you have to take. Suppose if you substitute that one over here and this one over here and square it upon both sides, 2L gets cancelled, G also gets cancelled. What will now be remaining over there? You check it. 1 by sin theta minus mu cos theta. That now becomes 4 by sin theta, like you will be getting. Why 4? You can understand 2 square now becomes 4. So automatically 4 sin theta minus 4 mu cos theta, that now is going to be simply sin theta. If I just bring this one over this side and this 4 mu cos theta the other side, automatically you will be getting 3 cos theta. That is now going to be 4 mu. 3 sin theta is now going to be 4 mu cos theta. This is the equation ultimately you people are getting. Now what is the coefficient of friction is the question. Mu is equal to 3 by 4 of sin theta by cos theta. What is sin theta by cos theta? It is tan theta. Tan 30 degrees he has given there. That of course you people can understand the value over there is 3 by 4, right? 4 mu. 4 mu means that mu is to be now taken up like this directly. Mu is equal to 3 tan theta by 4. Simplify this one directly by writing tan theta as 1 by root 3. This now becomes root 3 by 4. The option is going to be the very first one. One of the excellent models as far as EAMCET that is concerned. Let us now check the next number, that is 7. A van is running at a speed 72 km per hour on a level road where the coefficient of friction between its tires and the road is 0.5. The minimum radius of curvature the road must have for safe driving of the van is how much? G being 10 meter per second square. This is also altogether a different model, because whenever we people are having a circular road or a turned road, like we used to bank that road to avoid falling or skidding on that particular road as such. Now in this particular case, there is a level road, no doubt absolutely in that. Its radius is supposed to be how much? That means it is a turned road, no doubt, but it has not got banked there. That means what we should understand, only frictional force can save the personality not to fall on the road when he is moving with a vehicle like that. That means what? The so-called centripetal force acting on the personality and force of friction that is acting on that vehicle, as long as these two are equal, the person can move very safely over there. That means what is the equation here? Mu times mg, which is the force of friction, that now must be equal to mv square by r. That is in fact the equation what is to be taken up. Out of that, m gets cancelled. Means what? Whether the vehicle is a two-wheeler or a four-wheeler or a very heavy vehicle, hardly that matters. We need not take that one into consideration at all. So minimum radius of curvature, that means we just want the value of r, that is nothing other than v square by mu g. This is the concept actually what we people have to take up. Right? Velocity has been given 72 km per hour means 20 meter per second, that is 20 square, by the value of mu is given 0.5 and as usual g is given 10. So it is now 400 by 5 directly. This of course you can understand that now going to be 80 meter, exactly the very first option that is coinciding with that. So that is the concept there. Now come to the next number here. The power that the engine must develop in order to take the vehicle of mass 2000 kg up an inclined plane of slope 1 in 10 at constant speed of 10 meter per second, if the frictional force is 200 Newton will be. Underline the concept here carefully. Up an inclined plane, body is not sliding down, it is now going up. That is the concept we need to remember. And that too, it is an inclined plane, you should understand. When we consider a block of mass m that is on the inclined plane, the force that is required to move that one up, that is going to be mg into sine theta plus mu cos theta. That is the ultimate formula we need to take up. Out of that, mg sine theta you write it separately, plus mu mg cos theta. When you write this value, this of course is called force of friction over here. This value in the problem is given 200 Newton. And mg sine theta he has mentioned over there. But what is this logical wording here? 1 in 10. 1 in 10 in the sense what? Sine theta must be 1 by 10. That is actually the concept. 1 in 10 means what? Simply speaking, if you go this way by 10 meter, you will be raised by 1 meter over here. That is the logical concept over here. So sine theta must be 1 by 10. Now naturally you can substitute that value here. And of course weight he has given, mass is given 2000. So what can we write? M is 2000 into g, that is going to be 10, and once again this sine theta is again 1 by 10 plus what is this value of coefficient of this force of friction that is given? It is 200 Newton directly. Whatever this effective value you people are getting, come on, check that one here. You will be getting this one is going to be the force over here. This now gives you into 10. You will take by any chance, like you will be getting the total value 22,000 kilometer, 2,200 you are getting into the value of g that is taken common over there. So 22,000 kilowatt means watt, like that. That now can be taken 22 kilowatt as such the answer. So very first option that is coinciding here. Come to the next number please. A uniform chain of length L hangs partly from a table which is kept in equilibrium by friction. The maximum length that can stand without slipping is L, small letter. Then the coefficient of friction between the table and the chain is how much? That is the concept. One thing you should understand here, whenever a chain like thing that is hanging a small portion like this from the table, then what is the consideration here you need to have? Weight of this hanging portion and the force of friction that is acting on that portion which is kept on the table, both are supposed to be equal. When they are equal, then only the system can remain in equilibrium. Otherwise, the total system will fall. That is the concept there. So, what exactly the concept you have to take? For example, if I take this one as small l, this one as totally capital L minus small l, because total length, if I consider it as capital L, this now becomes L minus L. That is the concept. Now, what is going to be its weight, please? Total mass is m, mass per unit length, if I take it as m by L, that into small l, that gives you the length of that mass of the hanging portion. That into g, that becomes weight. That now should be equal to mu times the force of friction acting on this. What is force of friction acting on this one? It is again mass per unit length into what is the length of this portion? L minus L, right? That is actually the case, into G. Now G gets cancelled over here, M by L gets cancelled over here, then mu becomes simply L by L minus L. So hereafter every one of you can remember this formula directly. It is the length of hanging portion divided by the length of the portion which is right on the table. L by L minus L, that is now going to be the coefficient of friction that is acting on it. So that is the concept which is a very important model again. Now let us check the next number here, please. The coefficient of friction between a hemispherical bowl and an insect is root of 0.44 and the radius of the bowl is 0.6 meter. The maximum height of which an insect can crawl in the bowl will be how much? This is also one of the interesting most questions based on friction. Suppose there is a hemispherical bowl here. Imagine there is a small insect over here. This insect is slowly crawling up. But we used to see many a number of times after reaching a particular distance, that insect once again falls back. Once again it tries to come up like that, once again it falls back. That means what you people used to observe here is, if I consider the radius over there is r, the same also will be the radius. If I consider m is the mass over here, weight will be mg. And what are the possible forces they are acting on that? You take this angle is theta, the component of mg, this side will be mg cos theta and this side will be mg sin theta. But common sense says, when you are talking about this particular force with which it is coming back, frictional force that is always going to act that side opposing this force. That means what is frictional force over here? It is mu mg cos theta. Now simple logic over here is, as long as these two are equal, that particular insect can stay there. It will not fall down. That is the concept. So if you equate them, mu must be equal to tan theta. That is the concept. And of course, basic mathematics, of course, every one of us we know. If I take this one as a right angled triangle, this one as theta, when tan theta is given mu, opposite by adjacent is equal to mu. That means mu by 1, that of course is tan theta. So you can understand the hypotenuse value will now be mu square plus 1 over here. That is a concept under root you can write. So if you take this one, what is the height it is rising? That is the question. If you want height to be calculated, then what is the way you have to calculate? This is the total distance called radius, and this particular portion is nothing other than r cos theta. You can understand r minus r cos theta will give you the value of height. Then what is this value? R into 1 minus cos theta. From this triangle, adjacent side by this hypotenuse, 1 by root of mu square minus 1, that now becomes cos theta over here. R into 1 minus 1 by root mu square minus 1. What is mu given? You see here, root of 0.44. Now square this one up. 0.44. You people can understand straight away. 1 plus 0.44. This of course squaring up. You people can get directly this one. Now you will be getting the value of 1 minus 1 by root of mu square plus 1. What is the radius that is given? It is 0.6 that is given. So 0.6 into 1 minus 1 by 1 plus 0.44, 1.44 under root. This of course 1.2 we will be getting. 1.2 minus 1 is going to be 0.2. Directly we people can understand 0.2 by 1.2 directly. Whatever the value you will be getting here, h, that now coincides with 0.1 meter like. That is going to be the total height to what extent that insect can crawl. Remember this formula thoroughly. This is the concept there. Come to the next number here. This is a body sliding down an inclined plane having coefficient of friction 0.5. If the normal reaction is twice that of the resultant downward force acting on the incline, the angle between the inclined plane and the horizontal, normal reaction is twice that of the resultant downward force. That is the clue. What is the normal reaction acting on a body on an inclined plane? Normal reaction will be mg cos theta. And what is the force with which the system is coming down like? You people can understand that one as mg into sin theta minus mu cos theta. That is actually the formula for downward force. Here it is given normal reaction is twice the downward force. 2f you have to write. Mg cos theta over here is equal to 2 mg sin theta minus 2 mu mg cos theta. That is the equation. Then naturally what happens over here, you people can understand what is the question there. What is the angle between the inclined plane and all? And the value of mu is given 0.5. When 0.5 can be written 1 by 2, mu and 2 they get cancelled. Minus mg cos theta coming over here, 2 mg cos theta, that now is going to be 2 mg sin theta. 2 getting cancelled, mg getting cancelled, sin theta and cos theta are equal. Means what must be the angle theta here? 45 degrees. That is a concept. The answer is going to be the third one in this particular case. That is the question number 11. Now when the engine is switched off, a vehicle of mass capital M is moving on a rough horizontal road with momentum capital P. If coefficient of friction between the road and the tires of the vehicle is mu k, the distance travelled by the vehicle before it comes to rest is how much? This particular question, if you look at, there is a slight variation. So far whatever the questions we have observed, this is based on the concept of dynamics as well. When the engine is switched off, vehicle of mass m is moving on a rough horizontal road with a momentum p. Momentum is p and the value of mass is given as m. Coefficient of friction, that of course is given as mu k. Now the distance travelled by the vehicle before coming to rest is the question. In fact, momentum is nothing other than mass into velocity. Then what will be the initial velocity of the body? It is nothing other than momentum by mass. Momentum is m into u. Now u is equal to p by m. Now what is the final velocity supposed to be? It should be 0 because the body should come down to rest. That's what has been given. And mu is given means mu can be written as a by g. Then what will be the acceleration over here? It is mu k times g. This is the ultimate data provided to us. What is the distance travelled? Again u square by 2a. V square minus u square by 2as is the equation. Therefrom you can write u square by 2a here. U square now becomes p square by m square. right, into 2 into A now becomes mu k into G as such. Now come on, coincide with that option there please. P square by 2 mu k into m square into G, the very first option that's going to be tallied over there. So that is a concept here. A block of mass 10 kg is acted upon by a horizontal force 120 Newton. If the coefficient of friction is 0.5, its acceleration would be how much? Once again a question based on horizontal force applied on the body. The body of mass m, suppose, is applied upon by a horizontal force this way, the weight being mg, normal reaction being r, the force of friction being mu r, which now can be written as mu times mg. That is the concept. What will be the acceleration here? Applied force minus force of friction by mass. That is ultimate acceleration formula. What is applied force over here? It is 120 Newton is the applied force horizontally applied on the body. Minus, what is force of friction? Mu times mg. Mu being 0.5, m being 10, g again is going to be taken as 10. 10 into 10, of course, it is 100, m into g, into 0.5, that is half. So it is going to be 50. By what is mass again? 10. After all, it will now be 7. Straight away, you will be getting meter per second square. This is the acceleration of the body. So ultimately, one should remember this as the formula for acceleration of the body in the horizontal direction. That's the question 13. Now come to the next number. The minimum force required to move a body up an inclined plane is 3 times the minimum force required to prevent it from sliding down the plane. If the coefficient of friction between the body and the inclined plane is 1 by 2 root 3, the angle of inclination of the inclined plane is how much? Once again, be a little careful with the wording what has been given there. The minimum force required is to move up an inclined plane is 3 times. Up an inclined plane, what is the formula first of all? mg into sin theta plus mu k cos theta. That is the formula for force which is required to move up. That is the one point. And it is equivalent to what? 3 times the minimum force required to prevent it from sliding down. The force to slide down is going to be mg into sin theta minus mu k cos theta. Now according to this given problem, mu up must be equal to 3 times the value of f. Come on, equate them now. If you write mg into sin theta plus mu k cos theta, that is now going to be 3 times mg into sin theta minus mu k cos theta. That is the formula what we people are having here. Now mg both sides you can cancel that one off. Sin theta here plus mu k cos theta towards left you will be having 3 sin theta minus 3 mu k cos theta, that you are having towards your right. Now bring this 3 mu k cos theta this side, 4 times mu k cos theta, that now will be 2 sin theta over here. 3 sin theta minus sin theta, that automatically becomes 2 sin theta here. Now the question what is asked is, what is theta? This cos theta, if it goes that side, you can write this one as tan theta. That of course is equal to how much? 4 mu times k by the value of 2. Sin by cos is tan. 4 mu k by 2. What is this value now? Twice mu k. What is mu of kinetic frictional coefficient given? 1 by 2 root 3 that is mentioned. Root 2 gets cancelled. Tan theta is becoming 1 by root 3. Then automatically you can understand theta is going to be 30 degrees again. So this third option is going to be the right option for it. But remember what are the forces we people are writing here. That is the concept in problem number 14. Check the next number. The horizontal acceleration that should be given to a smooth inclined plane of angle sin inverse 1 by L to keep an object stationary on the plane relative to the inclined plane is how much? One of the excellent models again, because usually the body when it is there on an inclined plane like body, every chance for this body to slide down when this is the angle of the particular inclined plane. The body is to come down, we know, but here the question is something different. You should apply some force on this one with some acceleration A, such that this body should not slide, it should be there only forever. Means what? That is a condition, the object should be remaining stationary on the plane relative to the inclined plane. That is a condition. When I consider this is weight, this one is the normal reaction that is acting. We can all understand well, this being theta, r cos theta will be the upward component, r sin theta will now be the this horizontal component in this particular case. In fact, it is not horizontal component. For this angle, this becomes a vertical component. That becomes horizontal component over here. So, what must be the condition here? R cos theta must be compensated by mg. Exactly in the same manner, r sin theta must be compensated by the force whatever that is acting over here as ma. Now, if you just take sin theta, r sin theta by r cos theta, that now becomes tan theta is equal to a by g. We people are getting like. The point here in this case is, when you take, what is this sin theta mentioned over here? Sin inverse 1 by L, that means theta is equal to sin inverse 1 by L. When we take up, sin theta can be written as 1 by L. That means every one of you can understand, opposite side is 1, L is going to be the hypotenuse. Then what will be the adjacent side here? L square minus 1. Ultimately, what theta we people are having here? It is tan theta. What will be tan theta according to this triangle? 1 by root L square minus 1. That now is going to be a by g. Now cross multiply that one. A will be g by root of L square minus 1. That particular equation is given as the first option over there. That itself is the correct answer for this question number 15. Now check the next number here. A body is sliding down a rough inclined plane. Coefficient of friction between the body and the plane is 0.5. The ratio of the net force required for the body to slide down and the normal reaction on the body is 1:2. Then what is angle of inclined plane? In all these models, almost model is looking the same, but wording is different and formulae what we are taking up are totally different. Here the question is 1:2 is the ratio of what? Net force required for the body to slide down. What is the net force required for the body to slide down? mg into sin theta minus mu cos theta. That is the net force required for the body to slide down on an inclined plane. That is divided by normal reaction. That is a concept given. What is the normal reaction here? It is nothing other than mg cos theta on an inclined plane. That ratio is given 1:2. Now you can cut this one over here. Cross multiplication gives you 2 sin theta minus 2 mu cos theta will now be equal to cos theta once again here. Now the question of mu is how much? It's given 0.5. 0.5 means again 1/2. 2 and mu they get cancelled. If you take this cos theta that side, once again 2 sin theta, we are getting it as 2 cos theta. Means what? Sin theta and cos theta are equal or tan theta is equal to 1. That implies theta must be 45 degrees. That is going to be the angle of inclination of that inclined plane as such. That is the question number 16. 17, a very interesting model here. A man slides down on a telegraphic pole with an acceleration equal to 1/4 the acceleration due to gravity. The frictional force between the man and the pole in terms of man's weight W is how much? Concept here is he is coming down, he is sliding down an inclined pole with what acceleration? Acceleration is equivalent to g by 4 that has been mentioned. But already acceleration due to gravity that is acting on the personality there. Then what will now be the relative velocity, relative acceleration please? Relative acceleration becomes g minus g by 4. That means it becomes 3g by 4. Then what will be the corresponding weight of the personality? It now should be equal to 3/4 the weight now. That means if I take the weight of the person while sliding down the particular pole, that now should be how much? When G is becoming 3/4, automatically the weight of the person also becomes 3/4. So what will be the total weight of that personality now? It will definitely be 3/4 the original weight. Since original weight is given as W, 3/4 W will now be the present weight of the person whosoever is coming down on that particular telegraphic pole. That is, option is going to be the third one for this particular question number 17. Look at the next number, that is 18. One of the questions where we people are finding a figure oriented model. Here the question is says a block of mass M is pressed against a vertical wall by applying a force P at an angle theta to the horizontal as shown. As a result, if the block is prevented from falling down and mu is coefficient of static friction between the block and the wall, the value of P is how much? That is the question. Just look at the figure carefully what has been given first. This is the force that is applied on the body. What is the force value given? It's P. And at what angle it is applied? It is theta. So first and foremost, when we consider its mass as M, its weight will be acting downward as mg. We know that is one of the forces acting. And what are its components? See its component, horizontal component. Firstly, it is P cos theta. And of course, you can understand in the downward direction, you will be finding P sin theta that is acting on this. So what you people can understand straight away in this particular case is, when this is P sin theta here and mg is here. Now when you are applying a force here, what will now be the normal reaction that is acting on the person body totally? It is mg plus P sin theta. That is actually the normal reaction whatever that is acting on the body. Now if you take up this particular concept, what is the condition for this body not to fall? That is the condition. So what is the case here? As a result, if the block is prevented from falling down, that is the question. Prevented from falling down means what? The downward force, whatever that is acting, and upward force, whatever that is acting, both are supposed to be equal. Then how can I just write this one in the single step, like instead of writing several steps, like the force of friction acting upward must be equal to mg plus P sin theta. What is the force of friction over here? It is mu mg cos theta. That actually is the concept over here, that mg is nothing other than the weight here, and what is the normal reaction that is acting over here? It is P cos theta. So directly we can write mu times P cos theta, that now is going to be mg plus P sin theta. This is actually the case when there is no friction. But in fact, we all know very well, mu times when friction is there, that actually is the case. What is the question he is asking? What is P the question? Bring this P sin theta this way. P into mu cos theta minus sin theta, that now becomes mg. So if you want P, take this one to the other side of it. Mg by mu cos theta minus sin theta will now be the resultant force that is acting, which of course exactly is coinciding with the third option of this particular question. So third option is the correct option for this question as such. Now next question over here, a number of identical blocks, each of mass 0.4 kg, are placed one over the other. The minimum horizontal force required to pull the eighth block from the top without disturbing the remaining is 10 Newton. If G is 10 meter per second square, coefficient of friction between any two blocks is how much? In this particular concept, a bit of logic is needed to be applied. When we people are placing several coins or several blocks one over the other like this, let us consider there are several. He also has not mentioned in the problem how many like that. Let us consider this is going to be the eighth block from the top. That means how many are above this one means you can understand there are 7 blocks again about that one. And if you want to pull out this eighth block, a force of friction due to these 7 bodies will act over here. due to the weight of the 7 blocks, you will be finding a force of friction acting like this. Likewise, one more force of friction below the surface also that is going to act. How much is going to be this force of friction? Including the 8th body's weight, you will be finding the force of friction. This is F1 and this is F2. If I take, F1 becomes mu times 7 mg because 7 blocks are above that one. Exactly like that, F2 if we take, that is now going to be mu times 8 mg. Why 8 means below this surface if you want to take up, including your 8th body, 8 masses of course will apply some force in the downward direction in the form of weight there. Then automatically, what is the applied force supposed to be? It should now be equal to F1 plus F2. That is the concept. 8 plus 7, it's now going to be 15 times mu mg. That in fact is the formula for us. What is the value of g given, you know? What is the mass that has been given, you know? 15 times. What is the value of mu that is mentioned? It is again going to be the value of that. What is the frictional force is asked over here. What is the applied force here now? The applied force is how much? It is 10 Newton, remaining is 10 Newton, right? So 10 is equal to 15 times mu into what is mass given? That is 0.4 into g like. Now just calculate the value of this mu. This 0 and point gets cancelled. 1 by 6 will now be the value of coefficient of friction, which now coincides with the second option of this particular question. So one of the excellent models here also once again. A gun of mass 50 kg fires a bullet of mass 0.5 kg with a velocity 200 meter per second. If the gun moves back through 1 meter before coming to rest, the frictional force on the gun. Sometimes they used to give at EAMCET level some linked up models. This is one such question where you are finding the application of this dynamics as well. 50 kg gun is firing 0.5 kg bullet at 200 meter. According to the conservation law of momentum, we can equate the magnitudes of momentum of the bullet as well as that gun, please. So it is 50 times V will now be equal to what is the mass of the bullet that has been given? It's 0.5 times the velocity that has been given over there is simply 200 meter per second. 1 0 and 1 point, if you cut it off over here, V now becomes 100 by 50, which now becomes 2 meter per second. That means what? 2 meter per second is the velocity with which the gun is recoiling backward. When you take this as the initial velocity of the gun and final velocity is 0 because it has to come down to rest and it has travelled by a distance 1 meter, come on, taking these 3 into account, you find acceleration first. U square by 2g the formula. U square being 4, 2g being 2s, of course you can write u square by 2s, that is going to be 2 meter per second square, that is acceleration. But in fact we want the value of mu, which now can be taken as a by g. Then what will now be the value here? Mu is given there, that is the force of friction, frictional force we just want. So what is mu here? It is now 2 by 10, that is now going to be 0.2. Now what is force of friction acting on that? It is nothing other than mu times ma, that is mg. Just substitute the values over there. Mu is given, mass is known, g is known. Directly substitute, you will be getting exactly 100 Newton for this particular answer as such. That is the point. If you take the last number in this order as such, when two bodies are attached to one another, one hanging and the other one like this, if you can remember the formula directly for that, acceleration would be very easy for you. Acceleration is equal to m2 minus mu m1 by m1 plus m2 into g. What is what you should understand? M2 is the hanging body, mass of the hanging body. M1 is the mass that is on the table. Mu is coefficient of friction and g is acceleration due to gravity. What are the values given you see here? 10 minus 0.5 times. What is the value of m1 that is given here? That m1 is given 5 by 10 plus 5 becomes 15 into G being given 10. Substitute the values. Simplify this total thing. In fact, this becomes 2.5. 10 minus 2.5 is 7.5. 7.5 cancels in 15 twice. So ultimately 10 by 2 now is going to be 5 meter per second square. So like this, if you just apply the concepts of coefficient of friction over here, easily you can work out the question given at EAMCET examination final. And of course, one question surely you can expect from this particular topic, right? And have a nice time. And at the same time, I hope everybody can definitely do well the question given from friction. Thank you.